Hi, my name is Razvan Ionescu, and I'm a VMware leader for Romanian chapter and vExpert. I have experience with IT infrastructure, virtualized environments, private and public clouds. I'm currently changing jobs, but in the past I've been working for several companies from software vendors to telecom. For today, we'll take a look at Terraform, what it is, what it does, and how it can actually be used in a VMware environment. This topic came to me from an internal project that I've developed recently to support my developer team with complex development and test environments made out of multiple vCenter servers, vSphere clusters, NSXT, and VRA deployments. We'll not go that deep into details for today, but we'll just take a look at the basic concepts and some of the learned lessons. Terraform is an open source tool for infrastructure as code. Infrastructure as code provisions and manages the desired state of the infrastructure in a simple human-readable language. In our case, we're talking about HashiCorp configuration language, HCL. Now let's take a look at the provisioning workflow. So the first thing you do is to write how you would like your infrastructure to look like. So that, for the sake of the example, we'll go for 3 VMs, and each VM will be connected to its own distributed port group, and we'll put each VM in that folder. We just write this using HCL. Now, with this configuration file created, we will actually feed it to Terraform core. And doing that, we create a provisioning plan. The provisioning plan tells Terraform what it is supposed to do. What it does with the provisioning plan is it looks in the real world at what exists in the infrastructure, and it looks at the configuration file that we've provided, and it compares the two states, and it creates that provisioning plan. It answers questions like, does any of the artifacts in your configuration file already exist in the real world? If it does exist, do we need to update it, or just leave it like that? Once the provisioning is ready, Terraform will apply it, and it makes sure that our desired state is actually replicated to the real world. To do this, it uses Terraform providers. A provider is basically a connector to the outside systems. It can be the infrastructure layer provided through vCenter server. In our case, that's what we're going to see. And it can be a public cloud service. It can be something more complex, actually. It can be platform as a service, for example, Kubernetes provider. It can be even software as a service, a GitHub provider. Why not? At its core, the provider abstracts the API of the upstream systems, and it's the only way through which Terraform will communicate with those APIs and finally will ensure that the artifacts are deployed. Providers are managed by either HashiCorp itself, by the vendors, in our case by VMware or other software vendors, and also they are managed and created and managed by the open source community. You can find all the providers in a registry.terraform.io. For VMware environments, there is a vSphere provider created and managed by HashiCorp. There are also providers for NSXT, the Cloud Director, VRA, AVI. Those are providers that are created and managed by VMware. The vSphere provider manages the lifecycle of VMware vSphere resources, meaning virtual machines, ESXi hosts, data centers, data stores, vSwitches, everything. You can basically create the whole infrastructure, the whole data center from scratch and configure it using Terraform provider. At one of the core concepts that is brought in by Terraform is the immutability of the infrastructure. This means that once an artifact has been created, during its life cycle, it will never be updated in place. The only way to go from one state to another is by actually replacing that version of the artifact with the new version. So the artifact itself is unchanged during its life cycle. It is created and destroyed and replaced by a newer and better version. This is important. This is an important aspect because one should think about how the infrastructure is designed with thinking of immutability, and also more than that about the applications. Think about the VMs and the applications that are running on top of VMs, that they need to take into consideration the immutability of the infrastructure. Next, we'll take a look at a simple environment setup, and we'll go very fast for a bit of code for a project. So in this environment, there is a very basic configuration. There is a development environment, a laptop with a code editor. And since having all your code written and kept only on a laptop is never a good idea, you can also use repository in the cloud, such as GitLab in my case. It can be GitHub, it can be something different. On the dedicated VM, I'm running Terraform and Vault, two components. This dedicated VM is actually able to connect on one side to the code itself, and on the other side to the API, to the vCenter server API, in order to provision the infrastructure. The HashiCorp Vault is basically a secret management engine, and that I'm using here in conjunction with Terraform to keep all the required credentials safe. That's the only thing. It's, as its name says, it's a vault. I'll switch now to a small project, code project that deploys 3 Linux VMs from a VM template. It also creates the port groups for those VMs, and it creates the folders where to place the VMs. So as I said, it's a simple structure. I'm using 3 files in my structure, a Vault TF file, which contains the information about how to connect to Vault and which credentials to use. In our case, there is only one user, the user to connect to the API, to the vCenter server API. A very important file, I'm separating variables from main TF. It doesn't mean that you need to, it must be like this, but it's preferable to have variables separated from main file, from the main TF file, in order to be able to better manage it. In the variables file, we're actually putting here all the details, all the variables regarding connectivity to the vCenter server itself. So the hostname of the vCenter server, the user is being used. And since this is an environment that already has been configured, so there is a data center in there, there is a vSphere cluster, we need to specify those details. For example, on which cluster, on which data store, on each host, we create the VMs, to which virtual switch we connect those, to which virtual port group we connect those VMs, or which virtual switches we're using. All is put in here. Then we go and define how those VMs we want to look. So I said we want to have 3 VMs, and in this map, we have put here the hostname of the VMs. So basically the specific parameters of those VMs, the hostname, the IP addresses. As I said, we'll create the port groups, and we also create here the folders. For each VM, it's a separate one. And then we'll have some more details about the template. Basically, everything that you would normally enter in the vSphere UI and click it, it's put in here. Lastly, we have the main TF, where we declare how we want our infrastructure to look, right? First, we look at what the infrastructure looks like, what exists. So we read some information from the infrastructure in data structures here, like, for example, the host. And in the end, and then we go and create the port groups and the folders. And finally, we define how to create the VMs and from which template to clone them and what to do. So this is a very simple code sample. From here, you can expand and create complex infrastructures where you deploy and configure your nested environments with ESXi servers, with NSXT deployments, with Lifecycle Manager, VRA, whatever you can think of, you can actually code and put and deploy through Terraform. During the project, I've learned some hard lessons in the sense that, there are some things that first we did and then we read about them. One of the most important files in a Terraform environment is the tf state file. It basically contains the view of the world as seen by Terraform. Whenever it creates an object in the real world, it will also place that in a state file. Now, that state file needs to be protected, because if you don't have the information in the state file, then Terraform will not know if it was created by it or not in the real world. Another thing that's important in the state file, if Terraform manages credentials, even if those credentials are initially kept in Vault, whenever you deploy, for example, an NS6T manager and you put in there a password for admin user account, that password will also get written into the state file. Hence, the state file should also be encrypted at rest. Another lesson we've learned is that code doesn't always work on the latest version of a specific provider. So you may need to do a downgrade of the provider until your code runs one minor version or two minor versions. Use control source for two reasons. On one way, you will have a backup of your data, of your code, and then you'll have also a way to revert if any mistakes. The bigger the project becomes, you'll need to use modules, but don't over modularize. Sometimes you'll also need to do manual cleanup of the state file. If somehow a change has been done in vCenter, for example, manually, then there is again a desynchronization between the two. So you may need to go and do the changes in the state file. And lastly, not everything can be done with Terraform. Even if 90% of the job is done, you may need other tools to do that. Tools such as Ansible or simple things like scripts or CLI. So that's my short intro into Terraform for vSphere. Thank you for your time, and have a great VM world.